The vertex form of a quadratic equation allows us to identify the x and y coordinates of the highest or lowest point of the equation. That's why we call it the vertex form. In this video, what we will be doing is transforming equation from standard form to vertex form. Now let's remind ourselves as to what the standard form of a quadratic equation looks like. It is this here, this right here, and that is ax squared plus bx plus c. The vertex form of a quadratic equation, on the other hand, looks drastically different. It looks like this. Y is equal to a times x minus h squared plus k. Now, in this video, we will be using the completing the square method to transform our equation from standard form to vertex form. The first problem we will be looking at is this one here. F of x is equal to x squared minus 8x plus 11. F of x equals x squared minus 8x plus 11. Now, first thing we're going to do, we're going to change that f of x into y because right now it is in function notation form. It is easier for us to deal with y. So we're going to have y is equal to x squared minus 8x plus 11. Now, when we're using this form here, the completing the square method, we want to ensure that our leading coefficient is 1. In this case, it is 1 because if you look at what we have there as the first term in the equation, it is x squared. It is implied that when a variable is written without a coefficient expressed in front of it, the coefficient is 1. It is implied. It is 1. So x squared is really 1x squared. So this equation is already written in the form that we want it to be written. The squared term is already 1. Second step. The constant term, in this case it's positive 11, we want to move that over onto the left side of the equation. And in order to do that, we subtract 11 from both sides. So let's do y minus 11. And that will be equal to x squared minus 8x plus 11. And we subtract 11 from this right side to keep the equation balanced. So on the right side, the 11s will cancel out, leaving us with y minus 11 equals x squared minus 8x. From here, what we have to do is take half of the coefficient on the linear term and square it. The coefficient on the linear term in this case is negative 8. Half of that, well, it means that we divide negative 8 by 2. So negative 8 divided by 2 is equal to negative 4. Equals negative 4. That is the quotient when we divide negative 8 by 2. So we need to square that. Negative 4 times negative 4. That will give us a what? Positive 16. And that positive 16 will now have to be added to both sides of the equation, both sides. So we do y minus 11 plus 16. That will be equal to x squared minus 8x plus 16. Simplifying the left side, if we add negative 16, sorry, negative 11 to positive 16, what do we get? Positive 5. So we have y plus 5. That will be equal to x squared minus 8x plus 16. On the right side of the equation, what we have is a perfect square trinomial. And that can be factorized very simply. What we do is to turn that right side into a perfect square binomial. So we factorize it simply by taking half of the middle coefficient, in this case, -8, all right, and placing it inside the bracket with the leading term being x. Let me demonstrate that for you here. The leading term here is x. Half of -8 is -4, so that is going to go in our bracket. Close our bracket and square that quantity. Now, we rewrite the entire equation. The left side will be y plus 5, and the right side will be the quantity we have in bracket, x minus 4. So our equation now looks like y plus 5 is equal to x minus 4 quantity squared. In order to get this into the form y equals a times x minus h quantity squared plus k, which is the vertex form we're looking for, we need to subtract 5 from both sides in order to get that y by itself. So we have y plus 5. We're going to subtract 5. And we set that equal to the quantity in bracket here, which is x minus 4 quantity squared. And we subtract 5 from that right side as well. Simplifying, we will have y, because the 5's will cancel out, is equal to the quantity in bracket here, x minus 4 quantity squared minus 5. So we have successfully transformed our equation from standard form to vertex form. Now, something to bear in mind, the quantity in bracket, when we're going to plot it on the graph, is actually the opposite of what we will plot. In the graph, what we have is the x coordinate. This is -4 in the bracket. That's what we have. But when we plot it on the graph,